Yeah, hi, so we'll be talking about the difference between the van der Waals and ideal gas law. Firstly, start off with a gas inside a container. For an ideal gas, there are many molecules bouncing around inside off the walls. An ideal gas can be modelled by the equation pressure times volume is equal to the number of moles times the ideal gas constant times temperature. For an ideal gas, the molecules only bounce off the walls. Therefore, it is assumed that the molecules do not interact with one another. As the gas molecules are very small in comparison to the container, the second assumption is that the volume of the gas molecules do not affect the overall gas volume. Therefore, we can regard the volume of the gas molecules to be negligible. However, in reality, these assumptions do not truly reflect the nature of a real gas. Because of this, we need to find a more accurate equation that takes into account the errors created by the ideal gas law. The van der Waals equation does this by assuming van der Waals forces between the molecules of the gas. As the molecules are interacting not just with the walls but each other, the real pressure will be less than the ideal gas pressure. First we'll look at how the real pressure and volume relates to the ideal gas using van der Waals. The real pressure plus A times the density squared, all multiplied by the real volume minus the number of moles times B, is equal to the ideal pressure times the ideal volume, where A takes into account the van der Waals interactions and B takes into account the volume of the molecules. Both A and B are constants, specific to the type of gas molecule. As you can see, we have rearranged this equation and removed the moles to have it as a per mole basis. Rearranging this further allows us to see the relationship between the real pressure and the real volume using the van der Waals equation.